I think we are live. Hi everyone, welcome to another session at day 3 of TestMu conference. We are into the final day and sessions are getting more and more sharper. I am 𝐒𝐚𝐿, Developer Relations Manager at TestMu AI, and I will be the host of your session today. It's very good to have you all with us. Before we get started, just a quick housekeeping notes. Keep posting your key takeaways on LinkedIn and X and tag the speaker and use hashtag TestMuConf so the rest of the community can follow the conversation. We also have some very cool giveaways running, so it will be worth your while. And if you have any questions during this session, drop them in the Q&A box and we will take them during the end of the session. Now let's get right into the session today. Let me ask you one thing. How many AI projects have you seen that started with genuinely a brilliant demo and then it just stops? Never make it into production or never made it and quietly fell over 3 months. Almost everyone in this room had those kind of stories. And the interesting thing is that it is really the model that failed. What was uh, what failed was everything around the model: the data, the context, and the integrations, security, cost, governance. Whether a real person could actually use those things. All the unglamorous parts nobody put on those slides with the demo. That's the gap between the idea and impact. And this session is exactly to uh, close those gaps. In today's session, AI architecture thinking from idea and impact, we are we are going to discuss this exact thing. In this session, we are going to host Safeena. Safeena Banu is a principal technical evangelist at Elsevier. Safeena is going to walk us through an AI architect mindset, a structured way of translating a business problem into an actual solution architecture. Not only just models and prompts, but the whole setting, building blocks, data, context, integration, security, scalability, and user experience. Hi Safeena, how are you?
Hi, Sparsh. I'm great. Thank you. Thank you for this platform. I'm super excited to be here.
Thank you so much. It's a very exciting session. So I will just hand over the stage to you, and you can start.
Sure. Thank you so much. Hi, everyone. Good morning, good evening, whichever part of the world you're joining. I'm Safeena, like Sparsh introduced. I've been almost nearly 2 decades, and most of it has been in quality engineering space. I did have real hobbies before AI took over, but now all I do is build with AI over the weekends. And I'm here to share all of my experiences with all of you so that we can collaborate, learn from one another, and yeah, let's get started. I'll be sharing my screen and I shall present or view. Just let me know once my presentation is visible. Yeah, can you all see my screen?
Yes, Safeena. Yes, can you just
Yeah. Like Sparsh said, it is an idea to an impact. So, I've taken the use case of the QE quality engineering agentic stack we built out. And what are the architectural lessons? What are the viewpoints, mindset shift I had to go through, and what are the different layers? Think of it like the layers of this amazing cake. So, if the base is not strong, then you cannot build on it. And then what layer goes where, and how to exactly approach it is what we are going to be. I'm going to be sharing with you guys. So, what are we going to be covering here? So, the foundations, what exactly is an agentic QA system, the edges which mutate state and router, and whether it's multi agent, and how exactly you choose. And like I already told you, the layers or the building blocks, what are the tool layer, the model, the output contracts, execution state, long term memory, explicit control flow, and some of the principles which apply when you take the product to production, and things you need to be thinking about, which unfortunately we didn't start off thinking with that, but we learned it the hard way. So I'm here to share all about that. And finally, the synthesis, what are the takeaways, the end-to-end architecture, and the mindset or the things which you need to take care and you need to build in right from the start, where it is it is not very expensive in the beginning to correct a mistake, rather than when the trajectory gets wider, it gets more expensive. So like I said, we started building with one agent, right? And I thought like, oh, it's something groundbreaking. So every other person was building an agent, and it was fairly simple, and it seemed like magic unless it was not. And so the production, when we started scaling, it was like, can the system survive the task? So that was it. And then came the neighbors. So we started with one, and then we got all of these agents. So the demo which I'm going to be showing you is the full complete agentic stack. I will just show you the diagram. Up the next slide will have the diagram. Post that, I'll take you to the demo of the agentic stack, as well as another product which I have built for personal productivity, another AI related product. And then I'll tell you how I ideated, how I broke it down into layers, what are the things you need to take care of, what are the tips, lesson learned, and everything like that. And then I'll move forward. So here in the agentic stack, we have built a layer of different agents, for planning to authoring to a deterministic runner to a healer agent, as well as a deployment monitor. And the observability stack is the most important. These are the evals, which cuts across the layers, and it starts from the test planning and it moves to the deployment monitor. So there are several things here where you can read that, whether you need to ask yourself while you're building the agent. And then this is the agent stack. So when you look at this agent stack, I want you to focus on three agents which you will be seeing in the demo shortly. One is the feature planner, the locator inspector, and the quality reviewer. The rest of the loops will not get exercised here because it's not failing. We are looking at a happy path where everything gets so this guy is the main guy, which is a feature planner. To put things in context, we are talking about a playwright bdd typescript stack. This is for uit. We have similar agents also built out for apis, non-functional, and those are skills basically. And this this agent can call those skills on demand when, as and when the scenario you present it with. The feature planner calls locator inspector. This is the sub agent. This is the main agent. All of these are sub agents. The locator inspector does live inspection of the page, whichever page you give it. It interacts with it, takes a screenshot. We use MCPs heavily in this entire thing. Feature planner uses MCP from Jira because it reads the requirement from Jira. And then locator inspector uses playwright MCP. Of course, it's read only. It'll inspect everything, it'll collect all the information. This is with a cheaper model, not feature planner is the planner guy, so it uses the bigger frontier model like a opus. This I used to run it with haiku, now I run it with sonnet. It collects all of the information, it passes to the feature planner, and then it goes to all of these. All of evals are built inside all of these agents also, and the skills it calls also. And then it writes the repository tests and it runs them. There's a deterministic layer. This we don't give it to the model, we run it and we collect the results, and then we analyze the failure. Now failure can be multiple things, right? So it can't just go to the healer and say that, oh, fix the test. If it is a test failure, then it should go to the healer. If it is not, then it should inform the user, and it goes to the final the user gets informed. So all of these lives inside the code. The workflow orchestration lives outside the code. It is in ChatGPT, and I have an agent in ChatGPT, and there is a Slack trigger. So whatever information you collect and things like that is conveyed to us outside the workspace. So this is the layer. Now what I will do is I will stop presenting, and then I'll go into I'll just share my video. Maybe. Yeah, can you all see my screen?
Yes, Safeena.
Yeah, so this is the pack where we have the agents. Now I'm going to run it. Now I've recorded this because it takes a fairly long time and I wanted to cover the presentation as well. This is how the test repo looks like, and this is where we will be writing the locator code as well as the feature. So the artifacts which come out of it are the features, the locators, as well as the thing. So this is my demo script, the scenario, and I'll ask it to run my QE agentic stack. and then I'll ask it to run. I'm running all of this inside Codex. Sorry, I reversed it for a bit. Now it's coming in the thing. I'll have to fast forward it a bit so that I show you the main thing. So what running it in this harness Codex tells you is you can run it from anywhere. So I personally like to use Claude Code. I use GitHub Copilot and Claude Code a lot to author, and Codex is mainly my reviewer person. But here in this, the advantages is that you get to see the subagents with these cute little icons. So I told you this locator inspector is the subagent which gets called first. It is going to the all of these pages, it's inspecting, it's interacting with the elements, it's using Playwright. I've also asked it that you have to ask me every time you are navigating to a URL, so it will ask me. Now I'll say allow. So this is where the guardrails come, and this is where the kind of like rules and constraints come that you can actually ask it, and then it'll ask you, and then it'll start working. So I'm just gonna increase it a bit more so that it starts working on it. So you will see here locator inspection. Once the locator inspection finishes, it hands off to the feature planner, and planner takes the onus, and it'll start building the test, and it'll start working. So you can see all of the invocations and all of the traces also. So if you can see over here, it's called, right? It's finished, it's done. And the active guy, who's the active guy? The feature planner. So it goes and it calls the feature planner, and the feature planner is the guy who's actually writing the BDD scenarios, writing the step definitions, and it also has certain rules and guidelines built so that it kind of like it sees if it is already existing, what is the quality, and it is not just producing stuff, it is producing from a very rich context. So we spent a lot of time building the whole architectural layer, the contextual layer, where we say these are the things you should not do, these are the review comments, the previous review comments from the tests, right? So you will have to take care of security. And so when you actually click on quality review, I told this is the final gate, right? So once everything finishes, it gives to the quality review. So this guy has all of the end-to-end scenario, it is testing, and it is saying the gate is not just passing, but it should also follow certain rules. So if I'll just pause it a bit and move it over here, and if I think over here, you can actually see the trace. So if you click on it, you can see what are the traces, what did this guy do. And if you click on this locator inspector, it will tell you all the tools it has called, all the tool failures, and have logged certain information which is useful for our failure analysis for our future runs. This is the way we know what we have built is working as per expected or not. Okay. So then the quality reviewer gate is running. This is the final gate. Everything is passing clean. So it didn't go to the, I showed you in the flow that will go to the failure analysis and healer and all of that. It didn't do, because if it is failing, then it will obviously go there and it will record it or it will fix it, and depending on what is the failure reason, it will reflect on it, the reasoning model, and it will work on it. So there is a playbook, there are conventions, there are reusable framework steps. So it is actually checking each and everything of what I had told it to check, and then only it will produce the artifact. So when you come over here, it has produced these three artifacts: the feature file, the locator, and the steps. And sometimes it also creates utilities. It creates shareable steps. It will also identify and tell me which steps should go back into the framework, because right now I'm working out of a candidate pack. So we also have the framework pack. So there is a main guy and there is a main pack, and there are all these packs for each of the microservices. So this is one of the microservice where I am testing, and this is the Gherkin. And then also for Gherkin, we have these mandatory evaluations and things like that. So this is the flow. So I'll stop it. This is one of the demos. And then I wanted to show you all something else which I built for a personal productivity. So I have built this artifact where it is like a monthly AI learning map. So for every month, I give it my top priorities. This is what I give it. Okay. And it kind of generates a fresh focus. from 3 different places. It goes to the whatever blogs I have given it. It also identifies where. So it's from a founder lens, it is from a builder lens, and it is deep technical. So if you can see over here, if I expand it, it will tell me everything. Also from the official docs, any blogs I am interested, any deep thing and all that. So I can actually open the resource and I can start learning. If I click this, and then it will open whatever, it'll I think it'll open, it'll things like that it will do. And yeah, so this is what it is, and then you can check it, and then you can add your own resource if you want. And this is how I'm intentional about how I learn about AI. This is just for ideation. You can build something like this to make it easy for you. And then because it keeps changing, right, you can't be on top of things. And see, I started doing it from June, so whatever I've completed, this also helped me track, write my notes. So I moved from Notion. I used to use Notion earlier, and then I moved from Notion to this, because then I thought, why not build things like that? And I needed use cases, right? So this is one of the use cases I wanted to show. So I will be going back to the presentation right now. So yeah, so we were here. I'll just have to present once again, I think. I'll stop presenting and I'll present again. Yeah, so this is where we are. So earlier, like I told, we started off with a stateless model call, one-shot prompting. And how we ideated is we took all of the workflows. So we think in a workflow, right? So what are the workflows which generate the most value, make it more time? So what we should hand off to AI versus what we should do. This is where the ideation process came. And when we think about agentic QA systems, what are they actually? They are not just a model in a wrapper, but they're so much more goal based. And every person, everything it touches, every touch point of it, we need to understand what are the failure modes, and we build around the failure mode. So you're no longer prompt engineering. You are building a distributed system with a probabilistic component, which adds the complexity over here. Deterministic is fairly easy. You know what to expect, so you know what to test, right? So 5 agents, we were like one system. So the idea here is, then we got started when we were drawing it, when we took it to the drawing board, and like which should be a single agent, then which should be divided into sub agents, and how you should decide whether it is just an individual agent. So here I would like to say that you do not split because multi-agent sounds more complicated or advanced. Most people call an agent, it should be like, if it can be a tool, if it can be deterministic script or a function, let it be that. It should not be an agent, right? You split a capability only when it has a distinct responsibility, context, policy, evaluation, surface, or failure domain. If you're not able to justify or answer all of these questions, it should not even be an agent. So across all of my agents, if you see what it owns, the boundaries, and what it must not own is given over in this table. So if you see observability, traces, evals, cost, feedback, but it shouldn't be taking any action. It is for us, a human in the loop, to where the boundaries are. So agent boundaries follow ownership and failure domains, not prompt boundaries. So you have to make sure that you have to think in that direction, that why multiple agents at all, and whether we can have a single, keep it simple, scale, iterate often, fail, and learn from it, and then build the next layer. So, like I told you in the beginning, we started with that amazing looking cake, which had like this different layers, right? So you cannot ice a cake with no base, okay? And we have to go bottom up. It's not the other way around. So what is your first layer? It is the governance and the observability, where evals, I cannot stress enough on evals, and then you policy, guardrails, the cost, and the auditing. That is where you need to focus on. There is a difference between enforcement and guidance. You guide where needed, you enforce when needed. Enforcement is for all the critical things. You have to put an enforcement layer. What can be achieved by a GitHub advanced security, only that can achieve. You cannot inbuild saying that, hey, don't do this. You cannot write a statement saying that, because again, it's probabilistic, right? Somebody once told me an LLM is like a weather forecast. Like, LLM output is like a weather forecast. So you cannot control it. What do you control? You control the harness. You control all of the elements around it, so that you build an autonomous system where you have some sort of a predictable outcome. And the second one is context and memory. I cannot stress on this enough. Initially, we were like, okay, let's give it all the context, let's give it everything and all that, which resulted in something called context bloat, which also leads to context poisoning later on. And then you end up with the model doesn't really focus on what it needs to focus, and there is drift over there and everything like that. So you have to kind of like, you have to make sure that you have pruned it enough, and you give it at exactly the point you need to give and how much you need to give. So this is the things. And then it comes to the tool. This is the very important. This is like hands to the LLM, without which I think we all use MCP servers. While using MCP servers, you need to make sure that what kind of tools you give, whether you have to give read versus whether you have to give write, and where you have to give read, whether you're abstracting all of the fields. For example, if you are interacting with Jira and Confluence pages can be really huge, which all get fed into the context again back, right? You don't want it. So you identify treat it like an API. So take the output, understand, and parse the response, and understand what needs, and then pass it back to the model. And then reasoning and model routing. Here, judgment, like never facts, right? This is the thing where you choose the right model, whether to route it to the big model versus the small model. There is also a cost element over here. And then orchestration and control flow, whether it is a multi-agent system, where is a router passing it to a lot of digital workers, things like that. And finally comes the interface, which is the thing we see, whether you want to interact with a system which is close to the users, or whether you want to give it as a website, right? So this is where you draw the layers. So these are the edges in the system which can mutate the state. Never ignore all of this. So this is the thing which shapes the architecture, right? So context, tools, policy, traces, cost, everything like that. And whatever part is deterministic, you do not give it to the model. Okay, so you like the running of the tests and capturing of the results, that the model doesn't need to do. So you route it to a deterministic script which does it, captures the result, and then gives it to the healer. So wherever you can plug in some shell script, deterministic layer, do that. And where you need the model actual judgment, you do that. So I think you define the evaluation, you define the guardrails based on the access, based on the risk that carry. For read, it is the least. So no state change, it is required control is only audit. So write, so it creates a difference. Okay, so close schema plus path allow list. So depending on the access, depending on the risk and the side effect of, or the effect of it, you need to decide. If somebody asks why the runner, okay, so this is something which you need to focus on, and then we'll take it accordingly. So these orange boxes these are they are the gates, right? So this is where the write comes, and whenever there is a write, like I told you, you need to take higher caution and required controls you need to develop. So what exactly is autonomy? Autonomy is just delegated control flow, right? So you delegate the control in the right way, and you route it to the correct. So here choosing a model becomes your responsibility. Model selecting, it depends on what kind of a task you're going to do. So here the thing we did was, whenever the locator inspector was there, we gave it a smaller model, and we gave it only read-only tools. So it really doesn't need to do much, right? It needs to interact, it needs to capture, and then we already have rules written, and then when it gave it to the feature generator, the feature generator was the guy who has the frontier model. So in that case, you're controlling the cost also, and because this sub agent has their own context window, you're not flooding the main agent context, which is run by Opus. From all of the snapshots and all of the locator inspector generated a lot of output, right? So we didn't want it poisoning the context of the main agent, so we had to decide over there. And that is a change we made later on, where we put a smaller thing like that, like smaller model there where you needed. I started off with 𝐒𝐤𝐿, and then 𝐒𝐤𝐿 wasn't giving me the result I want, and then we switched it over to Sonnet. So where it exactly sits is, like I told you, it has a deterministic layer, and then generation strategy, whether it is a router, and then we have a multi-agent system right now. And then otherwise you can have a repo changing agent as well. So this is something like I haven't explored, but this is also you can do. So complexity should not be a reason to use an agent. Unenumerable control flow can be. Okay. So this is the micro pipeline, whether it is a single pipeline, whether it is a router plus workers, or it is a multi-agent. So it tells you across these different agentic patterns, what is the control flow, what states are, what are the states which get modified, as well as what are the failures, where it can go wrong, and how do we debug that. For example, if you have a multi-agent system, the trace is distributed. You don't write the trace at the end. You build evals across, and you write the trace so that you know at which point it failed, and it may be, you can go earlier and then you can fix it, right? Split a role only when context, permissions, evaluation, surface, and failure domain all differ. If they don't, you wanted a function, right? Multi-agent, you will have to think in the long run is a cost, not an achievement. So pay it only when there is an ROI, and when the failure domains are generally different. Yeah. So models for judgment, code for truth. So I've already spoken that this is a very, very important, decision you need to make, that what needs to be probabilistic, what needs to be deterministic. And if something is probabilistic in nature, how you're going to evaluate it. Okay. For deterministic, you can, for probabilistic also, you have different things, like you can have a golden data set where you have a subset of all your tests, as well as the outputs or even the edge cases. And don't just put the happy path, put an edge case, see how it is a thing. Or you can have LLM as a judge, where you have a rubric where it is grading against a rubric if it is a probabilistic output. And deterministic outputs are fairly simple, that you can put the evals according to that. And here I want to say that you have to put evals, not just, I think I mentioned it, not just in the agent but also in the skills. And you have to evaluate it going forward, whether it is you need to prune it, you need to kind of change it, please do it as and when you go. So tools are like APIs. Okay, you need to treat it as API contracts. So you need to decide what kind of input you're giving, how much of input you're giving, what is the output. Okay, if you don't know what kind of output you want, the model will not know. If you want like a 3-line, or if you want something which is not too extensive, if you want a JSON, if you want that is your output contract. You need to say what kind of a permissions you want to give. Okay, what kind of files you don't want it to touch. All that go into your hooks. Okay, pre-tool use, there is a hook. Post-tool use, there is a hook in Claude. If you go to Claude, if you're using Claude, you will have settings.json where you go and actually give explicit permissions. Okay, do not, of course there is a git ignore and all of that stuff, but still there are cases where the model has gone, it has either touched files it shouldn't be. I've faced that many times. Okay, and what kind of a structure you want for the result. Okay, so if your tool is accepting natural language authority, it's not good. You have moved your security boundary into the model. So you need to treat it like an API contract and give it everything it needs, and just extract what you need. Don't over This is where you can have, and here the failure mode could be tool call failures and things like that. So you need to also write it in your trace, saying that you need to whatever tools you're giving it, you don't need to give it /star, like how in the imports you don't import all of the libraries. As a best practice, you import what exactly you need. So in the tooling, you kind of don't give all of it tools in the beginning. Okay, so careful about the tool signature over here. So a production tool should make the safe action easy and the dangerous action impossible. If So that is something that is a takeaway from layer number 3, which is the tool layer. So we've covered the model layer, we've covered the tool layer, we've covered the architecture. And like I told you, this is giving a more technical example here, where read versus write requires different sort of guardrails and things like that. Close schema, path allow list, idempotency key, timeouts, when it has to retry, typed failures, audit records. So the model proposes a patch, it cannot apply one. This is like a property of a tool signature, right? Not of the prompt. So you have to think in all of those areas, in all of those fields, what can be injected, what can be removed, and things like that. So tooling is somewhere where you can think in this layer, that what are the kind of guardrails and what are the kind of you can even save context here and just give inject the right context via the tools at the right time. Context, this is you have to, this is a finite resource, so more context is not equal to good context, and shared source of truth is not equal to shared context window. Okay, so the counterintuitive point here is the instinct we all have is, just give it everything, let it take, the model is, I thought like the model is so brilliant enough, so smart enough that it can actually understand everything, it feels generous. But it's actually the fastest way to make an agentic system both expensive and unexplainable. You will see that once your context window crosses 50%, 60%, I stop. I compact it or I create a new session. That has been it, because initially when I used to work on these long goal commands and long things and all, my context used to fill up very easily because I didn't have this agentic layer in place, right? So, and also understanding here, how do you differentiate and structure the context, right? So in planning you might have different type of context, right? So you have requirements, you have confluence links, you have the change difference, risk history, prior defects. While you're authoring the tests, what are you going to give? You're going to give the API, UI structure, examples, okay, the plan, and the healer. In the healer, failing test. Here also, when you're extracting, like here we use Lambda test APIs, by the way, to because we run it in the web execution, so you can extract whatever information you need, but you extract just enough. Don't extract everything. Search grep for the error part and extract only the error specific and give it. And if it wants more information, let it ask you, and then you can give it. Okay, and also keep use memory, and keep the, if you feel there are any past repairs, healing incidents, something like that, which will help you in the future, right? You store it, you use the memory, you either use the procedural, you use the memory which the harness gives you, or you create your own structured memory. Be it, it can be an MD file inside your repository, it can be your memory design depends on the access, so how often you access it and how think based on that you can store. And once you scale, this memory becomes even more important, because it is most important for a agent to self learn from the mistakes, so that it doesn't repeat and you don't repeat the mistakes, right? And deployment is again the metadata, the health signals, the change of set, and observability, traces, outcome, model, tool version, overrides, all of these, right? The right question is not what does the system know, it like what it should know, what decision it should be allowed to know. Okay, so the this is a little bit complicated, but you will get it. The only thing is keep it lean, keep iterating on it so that it fails, and then you reflect on the failure and give it enough information. So if you're going to think that I am going to get it right in the beginning, it's not going to work. Like it may work if you're brilliant, like I wasn't when I started, like I started failing at every stage, and then I started recovering from the errors, and then I started asking that, hey, how can I improve it further? And that's how I moved forward. So layer number one, governance, authority, approval, autonomous healing in 6 different products. So here the interesting part is whether the agent can heal the test, it is what it is allowed to heal, and here the reasoning comes, how autonomous you want to be. So there's enormous difference between suggesting a locator change or just going and deciding and changing a test in a branch, committing the change, merging it with, while the whole organization trusted. Every step to the right increases the blast radius. Same model, 6 different risk profiles, 6 different architectures. So reads are recoverable, writes alter state. The more irreversible the action, the less autonomy you delegate. And that is a policy decision, not the model decision. So the interesting question here is not what agent can heal the test, it is who is allowed to believe the heal. Okay, so somewhere along the way here you might want to put human in the loop also. So I have, during my experimentation, we have decided which we want the human to not relinquish control. Like you have the 4 D's in AI fluency. If you see that, you also decide discernment. Okay, the 3rd layer, so you decide where the human comes in and how much of, because we are the ones who are accountable, so we need to make sure that we put human in exactly where it's needed. Maybe it a review in planning. Okay, the first stage, the planning, it's most important to have the human in the loop. So the model proposes, code validates, policy checks, human automation approval, tool execution, outcome is logged, and make sure that the important events you log it. Okay, here I think I spoke about it that evals need to be, it's a layer which cuts across. Okay, so you cannot like just build in the end and say that if the test is passing, that's not a good eval. Okay, what exactly the test should contain? Okay, what are the things you need to focus on? Is that there is requirement coverage, the eval in the requirement could be that, right? What are the gaps? Are there any non-functional requirements which we have missed? Okay, and scope planner chooses the regression scope, but there is human in the loop over here. Ultimately it's my decision of how much of testing I need to do and how much of testing I shouldn't do, right? And the runner has failed, the healer diagnosed, validate, pass the repair, policy decision approval, etc., etc. So evaluate the trajectory, not just the final answer. So you'll have to evaluate at every place. So example, if you're failing at level 2 or at level 3, that's better than going to level 5 using all of those model tokens of beautiful input output token and reaching to the end and saying that, oh my god, I have actually failed, and where exactly has it failed, and tracing it back. It adds not just to the cost but also to the human cognitive overload, because as it is, it over and I feel the problem which we all face is that the AI generates so much that sometimes for a human it becomes impossible to review and you know go ahead. So instrument these before you tune the prompt. When I say prompt engineering is way long back, but then it's still as important. Engineer your prompt and also engineer your system prompts. So if, whatever way you can pass the information, pass it, but keep it very lean, scale it where it is needed. And while you're building agents, keep it simple, and whatever you can pass it on to a skill, please do, because then that gets progressively disclosed. Our agents are fairly lean. It only contains the rules, only contains the tools, model, and some non-negotiables and some gotchas, maybe, which I don't want the agent to think. And then most of it, where if I see if it is can be passed on to a skill, we have skills. So for all the accessibility, performance, you can have skills for everything, right? So agent is just a way of orchestrating things. So put it in the put it in as a skill. So agentic system scale and decision density. So more teams, more repositories, more frameworks, more tools, more capabilities. It's just going to scale, right? Like you need to, evaluate cost also. So a cheaper model, it's not just as simple as choosing a cheaper model versus a frontier big model, right? Imagine you're using a cheaper model in a more decision making step or an important step. There you will lose more tokens because it'll keep asking 100 questions and it'll keep generating the result which is not good. So ultimately you will end up paying the same cost as you would have with a Fable, or okay, Fable we are not using now, or Opus, or a Soul. 5.6 Soul is very good, right? For so you can use that. So you will have to decide on what kind of the cost per transaction you'll have to see. That includes the model calls, retries. It's outcome based. If you've received a full outcome, you can test it with a smaller model versus a thing model and see which one works for you, and then you can go for it. Okay, so there are several ways you can measure it. There are skills for it. Also, there is a security aspect I need to warn. Please do not use a skill which is just having more stars in the GitHub thinking it's safe. No. Treat any natural language as code. Okay, make sure if you have not written the skill, you please doubt it. Okay, take it in a sandbox, put it in a Docker container, whatever is your way of evaluating it, evaluate it, but don't take skills just randomly. Try to develop your own workflow and then transfer it into a skill. That is something which we are very careful about. Even MCP servers, we as a company, we do not encourage or use most of the MCP servers which are not approved by our a team's security team. So decouple execution state from long-term memory. Memory is a whole topic in itself, but what I can tell you here, a tip is that structure your memory. Structure your memory and put it where it belongs, how often it is accessed. So it can be an S3, it can be inside your repository, it can be inside your own personal preferences. Like if you have a Claude, there are different layers. Like you could store it in your user library, you could store it in your harness, you can store it inside your repository. So there are different layers. The most priority is given to the memory inside your repository, and it goes upwards, right? So from bottom to up it goes. So retrieved context is an untrusted input carrying source identity, freshness, trust. Say it is trusted, never merge them. Okay, so you have to decouple the execution state from long term memory, and also keep aggressively pruning it. You don't need to write everything in the memory. You need to be very careful about what gets into the memory also, because then it can poison the context later on if it becomes stale. It can carry some this thing. Just truly write in the memory what it needs. The newer harnesses are quite good in that, but you also can write some sentences and things like that. For example, every time we do a failure analysis, if I feel that should be carried on to the next run, I have a folder called docs. I put everything inside docs, and then I run my analysis on all of those docs to see if things have changed. Maybe things would have changed. Maybe things are not standard. Okay, one off things, those don't need to get written into the memory. Then I prune it. Okay, so your test artifacts are attacker influenced inputs. So this is where you kind of, this structure will give you what are the injection surfaces. So based on mine are test agents, so not necessarily they are going to be a thing, but you need to treat it like code, and you need to understand what are the surfaces which can be attacked, like regex, maybe there is a dependency, there is a test fixture and things like that. What it can carry and how you have to control it. Like maybe you're from healthcare, there is a lot of regulation over there and things like that. So depending on what you're doing and where you're doing, you have to treat all of these artifacts as something which the attacker can attack, and how you can prevent it. Okay, so treat everything that reaches the model as a attacker control until proven otherwise. Cost and latency are architecture decisions. They are not a bill, so they're decided upfront. Okay, so how you limit your output, I think we've spoken different parts of it in different ways along the way, but this is how I would summarize it. Okay, cheaper model is not always cheap. Decide which model and reasoning level. Okay, so there is high, medium that you can choose, right? Like you can also set that as per the thing, and use the advisor strategy, or you sublet it to a cheaper model. Think through all the ways, and you can use AI to think for you. You can research papers, you can, there are a lot of people who have already done a lot of work. It's already available. Just identify the patterns, absorb it, and use it in your workflow. So this is the final synthesis. It's an agentic QE system end to end, and this is how you build in security, observability, trace, evaluation, cost, audit, and the killing switch. Okay. So right now, this is the framework which I use. These are the questions which I ask around framing, feasibility, bound autonomy, architecture, evaluation, piloting, and scaling. Right? So once I have all of these questions, I write it down. I'll see where the trade-offs can be made, and then I go ahead and build the system. So we have reached the end. Thank you so much for listening in. But these are the key takeaways. The goal is not the most autonomous system, trust me. It's the least autonomous system that creates the outcome you need and can survive being wrong. If you cannot name the contract, owner, failure mode, and success metric for a layer, it's not ready. So choose wisely, and think on all of these layers, be it the model, skills, tools, memory, control, and what you need to do. What are the controls you need to put while it is in production? Trust me, you will come out with a much more robust system. So thank you so much. I'm open to taking questions. Yeah.
Thank you so much, Safeena. It was a very wonderful session and very detailed layer by layer explanation. Sorry. Unfortunately, we are around 10 minutes past our time, so
Okay.
we will not be able to take Q&A. But I will share all those Q&As. There are some interesting question answers in the chat, and we will answer them over our blogs and YouTube videos.
Sure.
So,
I'm so sorry for going over the time.
Session was so detailed and so interesting that I didn't want to interrupt you, and I let it be go. But yeah, no worries. We will be sharing all the questions with you, and we will get it answered by you and share back to the community viewers. And like, if you need any help, please feel free to reach out to Safeena over LinkedIn. She's very active there, and she will help you out. So feel free to ping her and also tag her in all the takeaways or notes that we are sharing over LinkedIn and X. And at last, thank you so much, Safeena, for sharing all this information. And thank you all for joining us. We will see you in the next session. And yeah.
Thank you. See you. Have a great day. Bye.